KSP. KSP is one more aspect of the K expression. KSP looks at the solubility of objects, how they dissolve, going from a solid to aqueous, Ag plus and Cl minus. Unlike with our acids and bases, because we're dealing with solids, our Ka value, our K value becomes a little bit, the K expression is a little bit easier to deal with, because I'm looking up the KSP. Okay. All right. So the KSP is 1.6 times 10 to the negative 10th. Our KSP is just going to be equal to Ag plus Cl minus over 1. It doesn't matter how much silver chloride we have because it's a solid. So we never include solids in our K expression. Ag plus Cl minus. Now, just like we did with the weak acid, we don't know this and we don't know this. So we set them as X. This comes from our ice table. We set them as X. So if we want to find how much silver dissolves, KSP is equal to X squared. So we just have to square root KSP. Square root both sides. So 1.6, the square root of 1.6 times 10 to the 10th is going to be 1.26 times 10 to the negative 5th. So that's the molarity of silver chloride. The difficulty becomes if instead of silver chloride, you had something like lead chloride. And this is now breaking down into lead 2 plus and 2Cl minus. How would that change the expression? Well, KSP would now be equal to lead 2 plus and Cl minus squared. This would still be an X, but now, because there's 2 chlorides, this would be 2x. So our KSP would be x times 2x, or 4x cubed. So to solve for our x, you would have to divide both sides by 4 and then cube root. And that would take care of that. But even then, you would only be finding lead. If you were asking for chloride, you would have to multiply that by 2 again.